is not always obvious that any value of x obtained from a logarithmic equation will satisfy the equation or will not. In this lesson, I will show you how to validate a solution to a logarithmic equation. That is, how to test whether any given value of x obtained from the equation indeed satisfies that equation. But before we begin, let us consider log x. When we have a logarithmic expression such as this, x is called the argument of the log. Log must always have an argument. Remember, logarithm of 0 does not exist, neither does logarithm of negative numbers exist. And so, the value of x must be greater than 0. That is, x must be any value which is greater than 0. Suppose we have another expression such as log of x minus 1. The entire of x minus 1 is the argument to the log. This argument must never be 0. This argument must never be a negative value. That is to say, x minus 1 must always be greater than 0, which you can write as x greater than 1. For this argument to be greater than 0, the value of x must always be a number which is greater than 1. Let us look at an example of a logarithmic equation and apply this method in validating the solution to that logarithmic equation. Here is the example. Log of x plus 5 minus log of x plus 1 equals to log of 4 minus log of x. This is a logarithmic equation with several logarithmic expressions. We have a logarithmic expression with an argument of x plus 5. We have another logarithmic expression with an argument of 2x plus 1. And we have another logarithmic expression with an argument of x. Should any one of these arguments turn out to be 0 or negative upon substituting the value of x, then that value of x will be rejected. Whatever value of x we shall obtain, we will substitute into every argument just to be sure that every argument is greater than 0. We now proceed to solve this logarithmic equation. When we inspect the left side of our equation, we have two logarithmic expressions. When we inspect the right side, we also have two logarithmic expressions. From our previous lessons, we emphasized that the left side and the right side must have single logarithmic expressions. And because we have two, we must apply the laws of logarithms to come up with a single logarithmic expression on the left side. We must also apply the laws of logarithm to come up with a single logarithmic expression on the right side. And so we proceed as follows. The left side and on the right side we shall have 4x. I hope you remember the law which we have applied. That is, when we subtract two logarithmic expressions, we can divide the arguments and put under one log notation. Now, we have a single logarithmic expression on the right side, and we have a single logarithmic expression on the left side. The next step is a logical conclusion where we simply drop the log notations from the left side and from the right side so that we have this equation. We simplify this equation before we solve it. And so we proceed in our next step as follows. And so, open brackets. Right? And so we end up with a quadratic equation which we can solve. We break the middle term. And so we factorize. And we end up having x minus 4 plus 1 equal to 0. From this, x is either 4 or x is negative 1. We have two values of x. We are not so sure whether both values will satisfy our equation. We are not so sure whether only one value will satisfy the equation. We are not sure whether we will reject both values. So, we take each of the values and we test it on each of the arguments. If I take x equals to 4 and put it here, I shall have log 9. The argument is positive, and so x equals to 4 has passed the test with this argument. When we bring it here, again, our x is 4, and we substitute it here, we have 2 times 4 plus 1, which again gives me 9. Once again, x equals to 4 has passed the test on this argument because it gives me a positive value. When I bring it here, log 4, the argument is 4, which is positive. So x equals to 4 has passed the test on all the arguments. So we shall accept 4. Let us try x equals to negative 1. If I put x equals to negative 1 here, I will have log of negative 1 plus 5, which gives me log 4. And the argument is 4, which is positive. So x equals to negative 1 has passed the test on this argument. We bring it here. X is negative 1. We substitute it in this argument. That will be negative 2 plus 1. And negative 2 plus 1 is negative 1. The argument for this log turns out to be negative, and x equals to negative 1 has failed the test on this argument. And at that point, we don't have to proceed. Because x equals to negative 1 has failed here, it must be rejected. Between 4 and negative 1, 4 has passed the test on all arguments. Negative 1 has failed the test of this argument. And therefore, we shall reject negative 1, but we accept 4. And therefore, the correct answer to our equation is x equals to 4. Remember, whatever values of x that you get, you must test each value of x by substituting it into every argument of the log expression in the equation. Upon substitution, you will only accept that value of x if the argument turns out to be positive. If upon substitution in any argument you get a negative value, then you reject that value of x. Here is an exercise that you can try and use to practice on how to validate the values of x you will get from each equation. I hope you enjoyed the lesson. In our next lesson, we will discuss these examples. Thank you.